Hello, and thank you for joining me again. For this problem we're going to be working through, we're going to say that we're going to have a region bounded by the functions y equals x squared, y equals 0, and x equals 1. And then we're going to create a three-dimensional object by revolving this region about the y-axis. So what we need to do is we need to draw the region, and then we need to graph it three-dimensionally to figure out what that's going to look like, and cut out cross-sections in order to find the total volume. So we'll go ahead and graph those now. Alright, so I've graphed those three functions in order to find that region. So we have y equals x squared, x equals 1, and y equals 0. So the region bounded by those functions is going to be this region right here. Now, in order to revolve it about the y-axis, I'm going to imagine that I'm going to sit my thumb on the y-axis, pick a point that's in here, and I'm going to spin this around, have it coming out towards you, and then go all the way around to the other side, and I'm going to imagine that coming out into three dimensions. Now if I do that, what I'm going to end up with is, on this side I'm going to get something that looks like this. And then because I'm spinning it around, it's going to be circular. And so if I look at, say, a middle piece here, I'm going to have an outer circle. And then I'm going to have an inner circle. And then the inner circle is going to be empty, whereas the outer circle is going to be filled in. So if we draw this portion here is going to be included in the region that I've spun around, but the inner portion is going to be cut out. So what we're going to end up with is something that looks like a football stadium is the best explanation I've had, or some other type of sports stadium. Notice that it's cylindrical on the outside. On the inside I've cut out this bowl shape, so that I have a bowl cut out of a cylinder, and so that looks like the seating coming down to the middle where you would have the field or something along those lines. And so that's the basic shape that we're going to have here. Now in order to find the total volume, again, we're going to have to cut cross sections. And so we actually have two choices here. Is we can cut cross sections as shells, or we can cut cross sections as washers. And the big choice is, do we want to move our cross sections up and down, or do we want to move them left and right? Now for this one, I am actually going to draw shells, and I'm going to move them out, and I'm going to determine what the volume is going to be that way. Now if you would like to use washers, that's fine, and I've included a write-up of that along with a write-up of the shell method, but I only wanted to show one method just to give you an example of what's going on, and I'll leave the other one for you to read about. Alright, I've redrawn my graph with my shells drawn in. I wanted to declutter a little bit because there's a lot of things there. So now I've drawn it so that just the shell is showing. And what we see here is that the shell is really cylindrical with a very close cylinder cut out, so that we have a very thin outer layer here. And so I would imagine this looks like a can of soup with the top and bottom cut off, and you just have the outer shell remaining. Now, if we're cutting our cross sections like this, what we have to do is we have to find the volume of that cross section. So therefore, what we need to do is figure out what this looks like. And so the way I'm going to think about this is actually I'm going to imagine cutting this and pulling it out. If I do that, what I get is something that looks like this. And in fact, what that looks like is a lot like a rectangular salad. Now the height of the rectangular salad is just this height here, but since I cut this and I stretched it out, what I get is that this length here is in fact the entire length going around the circle, or that is, it would be the circumference of the circle at this point x. So what that means is that the length of this is going to be 2 pi times the radius. The height is going to be this height right here, and this depth is going to be this distance right here. So now if I look at that, I'm going to focus on depth first, and so this distance right here, notice that that's what we're going to try to make smaller and smaller. We're going to let that get infinitesimally small, so that's going to be our change in some variable. Since it's moving left to right, it's moving in our x direction, so our depth here is going to be delta x. So coming over here, our volume was 2 pi times our radius times our height times our depth. And so now we've determined that our depth is delta x. So now we just need to find our radius and our height. Our radius is just going to be this value right here, and actually that one's pretty easy too because that's just the x value that we picked for drawing the shell out. So our radius is going to be x, so we get 2 pi x. Now on the other hand, the height is this distance, so that distance is just the y value that corresponds to the function that we've drawn here. So now if we look at that function up here, that was the function x squared. So what we get is that our y value is our height is x squared. So what I get is that the volume of that cross section is 2 pi x times x squared times delta x. Now, if I want to find the total volume, I just have to add up all the volumes of the cross sections by integrating. So I get the total volume is going to be the integral from a to b of 2 pi, and now since I have x times x squared, I'll just write x cubed. And since we're letting delta x get infinitesimally small, we're going to let that be dx. So we're going to integrate from a to b of 2 pi x cubed dx. Now, the next thing we have to do is we have to find what is a and what is b is. A is the smallest x value I'm interested in. B is the largest x value I'm interested in. Notice that as I'm drawing these shells, I don't want negative x's because then I'm going to get positive x's and I'm going to actually double count things. So what I want to start with the shell method is with the circle of radius 0. So that is, we're going to let x be 0. Then we're going to let these get bigger and bigger and bigger until we get all the way out to this outer bound. And so this problem actually tells us that the outer edge is going to be at x equals 1. So for this, we're going to have that our total volume is going to be the integral from 0 to 1 of 2 pi x cubed dx. Now again, what we have is we have set up this problem. We found what the volume of the cross sections are going to be. We found the total volume, and we were able to plug things in so that we have all of the x values needed. Now all that's left to do is to actually find the antiderivative and evaluate by plugging in 1 and then subtracting off, plugging in 0. Alright, thank you for joining me for calculus practice. If you'd like to see more problems, you can check out the rest of this playlist available up here. Also, please sure to subscribe to the channel so you can see when we have more of these coming up. In addition to that, you can also check out the link available in the description below to see the written version of each of these problems so that you can pull that up to follow along with the video or to do on your own for extra practice. Thank you and good luck with your studying.